This video is about solving an equation using zero product property, factoring and solving a quadratic equation with an a value of 1, and factoring and solving a quadratic equation with an a value other than 1. So today we're going to work on some more factoring. Remember, as reverse FOIL. Today, however, there's going to be a number in front of our x. Pull out a GCF, which is a greatest common factor. So remember that we always want our equation to be x squared, but we're going to have to maybe pull out something that will make it an x squared. So usually the GCF is the number in squared. However, if you have an x cubed term, then you should look and see if each term has an extra x. If it does, you need to pull out an x as well. So sometimes you're going to pull out a number, sometimes you're going to pull out an x, sometimes you're going to pull out both. So we're going to start slowly by just identifying our greatest common factors. So in number 1, remember that we're trying to get this term to become x squared. Well, the number that's keeping us from being just x squared is 5. So we need to double check, are all of these divisible by 5? 5x squared is divisible by 5, 15x is divisible by 5, and 10 is divisible by 5. So our GCF is 5. In number 2, we want our first term to be x squared, but right now it is 2x squared. So the number that needs to be removed is a 2. So I want to check, are all 3 terms divisible by 2? So the first one we know is 28x is also divisible by 2, and so is 98 because it's an even number. So our GCF is 2. In number 3, we already have an x squared, and there's no number out front, so it's a 1. So if we look at our other terms, they're all just divisible by 1, so our GCF here would be 1. In number 4, we no longer have an x squared, we have an x cubed. And if you look at all 3 terms, they have one more x than they usually do, because it usually goes x squared x and then no x. So what we can do is our GCF is x, but everything would decrease. In number 5, we have 5x cubed. So there's 2 problems here. It's not x squared, it's x cubed, which means that we can factor out an x because everything has one more x than it needs. We can also divide everything by 5 because 15 and 20 are divisible by 5. So our GCF would be 5x, which would get us back to x squared. In number 6, we have 2x squared, and we just want x squared. So even though there's only 2 terms, we can still look at this, and we know we want to get to x squared. So our GCF is 2. So when we get to a GCF box problem, there are going to be 2 steps. The first step is to divide out the GCF from each term. We're going to write that in the front of our expression, and then we're going to find the numbers to write our answers in factored form and keep the GCF out front. So in this first example, we have 4x squared plus 32x plus 48. So we know that if we want this to become x squared, we got to divide everything by 4. So our GCF is 4. That goes out front. So we have 4 out front. We can divide everything by 4 then. So 4x squared divided by 4 is x squared. 32x divided by 4 is 8x. And 48 divided by 4 is 12. So we're going to bring our GCF down to our second step. And now we want to focus on the box problem like we've been doing. So we want to figure out what are 2 numbers that multiply to 12 and add to 8. So those numbers are 2 and 6. So we have x plus 2 and x plus 6, and then we are done. So it's one more step than we're used to. So in number 1, we have 5x squared plus 15x plus 10. We want to pull out our GCF. So in order to get this to become an x squared, we would divide everything by 5. So we have 5 out front, and we would be left with x squared plus 3x plus 2 when we divide. Now we want to box problem. So what multiplies to 2 and adds to 3? Well, the only numbers that multiply to 2 are 1 and 2, and those would add to 3. So we would have 5 times x plus 1 times x plus 2. We have 2x squared plus 28x plus 98. So to get it to be an x squared, we would want to factor out a 2. So if I divide everything by 2, I get x squared plus 14x plus 49. So now we need to figure out what are two numbers that multiply to 49 but add to 14. So those numbers are 7 and 7. So we have 2 times x plus 7 times x plus 7. Remember, if it's the same, we can write it as x squared plus 7 to the squared power. Don't forget that your GCF needs to stay in front at all times. Number 3, we have 3x squared plus 15x minus 72. So to get to become x squared, everything needs to divide by 3. So our GCF is 3. We're left with 3x squared plus 5x minus 24. So now we need two numbers that multiply to negative 24 and add to 5. So we're looking for two numbers with different signs, one positive and one negative. If we're adding to a positive number, we want our bigger number to be positive. So in this case, we would have 8 and negative 3. So we have 3 times x plus 8 times x minus 3. So in number 4, to get an x squared, we need to factor out a 4. So our GCF is going to be 4, and we divide everything by 4, so we get x squared minus 2x minus 8. So to box factor now, we need two numbers that multiply to negative 8 and add to negative. We need a number of each sign, a positive and a negative. So we could have, so we're going to have 4 times x minus 4 times x plus 2. In number 5, there's already an x squared, so we don't need to worry about a GCF. We can go straight into box problem factoring. So we need two numbers that multiply to 6 and add to negative 5. If we are multiplying to a positive but adding to a negative, both of our numbers have to be negative this time. So we would have negative 3 and negative 2. So x minus 3 and x minus 2. In number 6, to get an x squared, right now it is 3x squared, so we're going to divide by 3. So we would get x squared minus 25. Now, when you are box problem factoring, there's not that middle x term. That's okay. Remember, that just means that we are multiplying to negative 25 and we are adding to 0. So we want the same number, just positive and negative. So if we need to think about what's the square root of 25 is 5, so we would use 5 and negative 5. So we have 3 times x plus 5 times x minus 5. In number 7, all three terms have an x, but we only want the first two terms to have an x. So because it is x cubed, we want to take an x as our GCF out. So when we do that, we leave an x out front and everything decreases by 1x. So we have x squared plus 7x plus 12. Now we can box factor. So what are two numbers that multiply to 12 and add to 7? We're going to have two positive numbers. So we would use 3 and 4. So we put x out front as our GCF, and then we would have x plus 3 and x plus 4. In number 8, we have x cubed plus 9x squared minus 36x. We need to become an x squared, so we're going to take an x as a GCF out. So everything decreases, so it's x squared plus 9x minus 36. So we need two numbers that multiply to negative 36 and add to 9. So we're looking for one of each sign. So those numbers would be 12 and 3. And we want 12 to be positive because we're adding to a positive number. So we would have x times x plus 12 times x minus 3. In number 9, we have 9x cubed. We want it to become x squared, which means we need to divide by 9. And we need to take an x out. So 9x is going to be our GCF. And when we divide then, we get x squared plus 14x plus 24. So we need two numbers that multiply to 24 and add to 14. So those numbers are going to be 2 and 12. So we'd have 9x times x plus 2 times x plus 12. We're going to have problems that have an equal sign, so we're going to have to factor and then solve using zero product property. So in number 10, we have 4x squared plus 28x minus 176 equals 0. So the first thing we want to do is find our GCF. So in order to get an x squared, we know that our GCF is 4. So we're going to move a 4 out front. So when we do that, we divide everything else by 4, so we get x squared plus 7x minus 44 is equal to 0. Then we want to factor like we were. So what are two numbers that multiply to negative 44 but add to 7? Because we're multiplying to a negative number, that means we want one of each sign, but we're adding to 7, so we want our bigger number to be positive. So we would have 11 and negative 4. So we get 4 times x plus 11 times x minus 7 equals 0. Now we have our zero product property. So anywhere that has an x, either in the parentheses or the GCF, gets set equal to 0. Because this GCF is just a 4, we ignore it for the last step. So we just have x plus 11 equals 0 and x minus 7 equals 0. So when we solve, we would subtract 11 from both sides, so x equals negative 11. And we would add 7 to both sides, so x equals positive 7. Because it's an x squared term that the problem started with, we're only going to have two solutions at the end. In number 11, our GCF is a x squared. We're going to divide everything by 3, so we get x squared plus 17x plus 16 equals 0. So we need two numbers that multiply to 16 but add to 17. So we want two positive numbers. A lot of us are probably thinking 4 and 4, but don't fall into that trap because 4 plus 4 is only 8. So we need different numbers that multiply to 16 that add to 17. So we'd have 3 times x plus 16 times x plus 1 equals 0. For the zero product property, only our parentheses have the x. So we're going to set those equal to 0. X plus 16 equals 0 and x plus 1 equals 0. So we can subtract negative 16 from both sides, so x is negative 16. And we can subtract 1 from both sides, so x is negative 1. In number 12, this is not equal to 0. So the first thing we have to do is we need to move that 66x over. So I'm going to add 66x to both sides. So I would have 6x squared plus 66x plus 180 equals 0. In order to get to become an x squared, we want to divide everything by 6. So our GCF is 6, and we're left with x squared plus 11x plus 30 equals 0. So we need two numbers that multiply to 30 but add to. Those numbers are going to be 5 and 6. So we'd have 6 times x plus 5 times x plus 6 equals 0. So the two parts that have an x, so x plus 5 equals 0 and x plus 6 equals 0. In the first one, we're going to subtract 5 from both sides, so x equals negative 5. In the second one, we're going to subtract 6 from both sides, so x equals negative 6. In number 13, we have 3x cubed plus 39x squared minus 90x equals 0. Remember that we want an x squared here. So every term has an x. That's going to be part of our GCF. And every number is divisible by 3. So our GCF is going to be 3x. So we're going to decrease each x by 1. And we're going to divide by 3. So we're left with x squared plus 13x minus 30 equals 0. So now we need two numbers that multiply to negative 30 and add to 13. So we want one of each sign. So in this case, we wouldn't want 5 and 6 because that would only add to 1 or negative. 15 and negative 2. So we have 3x times x plus 15 times x minus 2 equals 0. Now, notice that this is the first time our GCF has had an x in it. So that one's also going to get set equal to 0. So we have 3x equals 0, x plus 15 equals 0, and x minus 2 equals 0. So in our first one, we're going to divide by 3. So x is 0. We're going to subtract 15 from both sides. so x is negative 15. And we're going to add 2 to both sides, so x is 2. So notice this time we had an exponent of 3 when we started the problem, so we're going to have 3 solutions in this case. So your exponent, the leading exponent in your original problem, will always tell you how many solutions to expect, 2 or 3. In number not ready to factor yet because it's not equal to 0. So we need to move the 12 over by subtracting from both sides. 2x squared minus 10x minus 12 is equal to 0. So we need to become an x squared, so our GCF here is going to be 2. We're left with x squared minus 5x minus 6 equals 0. Now, this is a tricky problem for a lot of people. Because a lot of people say, oh, 2 and 3. But when you are multiplying to negative 6 and adding to negative 5, 2 and 3 aren't going to work. Instead, we need negative 6 and 1. So we would have 2 times x minus 6 times x plus 1 equals 0. So our first parenthesis is going to be x minus 6 equals 0 and x plus 1 equals 0. We ignore the 2 because, again, it doesn't have an x with it. So in our first one, we add 6 to both sides, x equals 6. We subtract 1 from both sides, x equals negative 1. For our last problem, it is not x cubed, so our GCF 2x because we also need to get an x out of each term. So 2x, when we divide, we get x squared plus 13x plus 30 equals 0. So we need two numbers that multiply to 30 and add to positive 13. So it's not like the problem we did in 13 where we're multiplying to a negative. We're multiplying to a positive. So 2 and 15 are not going to work this time. Instead, we want to use 10 and 3. So we would have 2x times x plus 10 times x plus 3 equals 0. Each part with an x is going to get set equal to 0. So 2x equals 0, x plus 10 equals 0, and x plus 3 equals 0. So in the first one, we divide by 2, x equals 0. We can subtract 10, so x equals negative 10. And we can subtract 3, so x equals negative 3.